Hello everyone, welcome to our channel. This is question number 8 from exercise 1.1. In this a relation R is given, which is absolute value of A minus B is even. A and B are related if you have this condition. And it is defined on a set A which is 1, 2, 3, 4, 5. And you have to show that this relation is an equivalence relation. Okay. Now in order to show that a relation is equivalence, you have to prove that it is reflexive, symmetric as well as transitive. So first we will prove it is reflexive. For this reflexive, you have to take the same number A. So consider A minus A. A minus A will always give you 0. And 0 is an even number. So it is true for each and every A. So we can write that AA belongs to R for each and every A that belongs to capital A. And hence it is reflexive. For symmetric, you have to take a pair AB. AB belongs to R if you have this condition that mod of A minus B is even number. If you have absolute value of A minus B is even, that means absolute value of B minus A is also even. It implies that BA, the pair BA also belongs to R. Okay. So you have, if AB belongs to R, it implies BA also belongs to R. Therefore, it is symmetric. For transitive, you have to take two pairs. AB belongs to R and BC belongs to R. Now what we have to do, our task is you have to show that AC belongs to R. Now, if AB belongs to R, you have absolute value of A minus B is even. If BC belongs to R, you have absolute value of B minus C is even. If you have this A minus B is even, that means A minus B. Remove the absolute sign. So you will get that A minus B is also an even number. Similarly, if you remove this absolute sign, that means the term B minus C will give you an even number. Now consider A minus C. You can write this A minus C as A minus B plus B minus C. Just add and subtract B. So you get these two terms. Okay. So you have A minus B plus B minus C. Now this A minus B is even, B minus C is even. When you add two even numbers, you get an even number. That means this A minus C is even. Now you can put the absolute sign on this. So you have that absolute value of A minus C is even, and hence AC belongs to R. When AC belongs to R, that means it is transitive. So this relation is reflexive, symmetric, transitive, and hence it is an equivalence relation. Now one more condition, one more question is there, that you have to show that these two sets are not related to each other. As you can see, this 1, 3, 5 is an odd set, 2, 4 is an even set. So no element of this set can be related to this set, and no element of this set, even set, can be related to element of this set. But the set among each other are related to